video is going to be about the scientific process. I know you've talked about the scientific method before, but this one is going to take you through all of the steps, and then tomorrow in class we will do an example and a demonstration that shows all of these steps. So the first step is to start with a question. And questions can be really difficult to come up with because they need to be specific enough that you can test them and they can be answered. And a lot of times our questions will come from observations that we've made or experiences we've had and inferences that we've taken from our observations. So it's important to have a good question to start with. After you have your question, a lot of times we conduct a little bit of research. This is to find out some background information about your topic. What else is already known about your topic or your question? Has anyone tried this before? Are there any other studies out there that might already answer your question? And anytime you do research, you want to make sure that your resources or your sources are reliable. And this would be specific to the internet. So if you're using the internet for formal research, you wouldn't want to use unreliable sources such as Wikipedia. Wikipedia is great to get some real quick basic information, but for formal scientific research, you would not want to use a site like that. So you want to make sure your sources are reliable. The next step in the scientific method is to develop a hypothesis. And you already know what a hypothesis is, but this year we will be writing our hypotheses in an if, then, because statement. And so there's three parts to that. The if part, that's when you give a little bit of explanation about what you are going to test and how you're going to test it. The then part is what you think will happen, and the because part is why you think it will happen. So you have to have those three portions of your hypothesis in order for it to be a complete hypothesis. I will give you an example of this tomorrow in class when we do our demonstration. The other thing you have to make sure of when you develop a hypothesis is that it has to be able to be tested. So if your hypothesis is written in a way that there's no way to test it, then you need to reconsider your experiment or your hypothesis. And in the end, it really doesn't matter if you were right or wrong, because in the end you're learning something and your guess ahead of time really doesn't matter. After your hypothesis, you can begin to design and conduct your experiment. A lot of times at school, we're used to just going into the lab and doing the experiment, but what real scientists do is they actually design it. So when you design it, you have to make sure that it's answering the question you are asking. If it doesn't answer the question you are asking, then your design is completely wrong. And you need to have a way to get measurable data. If you cannot get measurable data, then you will have no way of knowing if your hypothesis was correct or not, and then you're not answering your question. A couple of other things that are important when you're designing an experiment are things to do with variables. And a variable is something that changes in an experiment. We have a couple different types of variables. An independent variable. This is the variable that is changed in order to test the hypothesis. So the scientist controls this. Okay, this is the thing that is being changed, basically the thing that you're testing. The dependent variable then depends on the independent variable. So it's the variable that changes in response to the independent variable. This is what you are gathering your data from. This is what you're measuring or observing during the experiment. Then in some cases there's a control, and that is when you're doing a test and it is not getting the material tested. The one we'll do in class tomorrow, I will have an example of this. So the control is the one that does not get the material being tested. And then of course data, you know that data can be numbers, but it can also be that qualitative piece. So it can be quantitative or qualitative observations that you are collecting during the experiment. So once you have your experiment designed, set up, and ready to go, as you are doing the experiment, it is important to collect data, because without data, then we don't know if our hypothesis is correct or not, or we're not really getting any information to answer our question, and that's the whole goal of this process, is to answer our question and gather information. So we have to make sure that we're gathering our data, and this can be done in a lot of different ways. Most of the time now, this is done digitally. So we're collecting and entering data on a computer. We're creating data tables to organize our information, and we will also be doing this year. After we have our data, now we need to evaluate or analyze the data. And so that way we can figure out what it means. A lot of times, scientists will begin to put this information in graphs or charts. They might find the mean, median, or mode. This is one way to evaluate data. And they start to really ask, well, what does this information mean? What do these numbers mean? Or what do these qualitative observations mean? And they start to relate it back to the hypothesis to decide, were we correct in what we thought, or were we incorrect in what we thought? At the very end of an experiment, it's always important to communicate your results, because really without sharing your information, it does no good for anyone. And that's the whole basis of science, is making sure that we're sharing our information, we're sharing how our experiment went, the data that we gathered, and that's how we learn from each other. And scientists do this in a lot of different ways. So they'll give presentations, they'll write journal articles, internet articles, and other scientists even review and repeat each other's work to make sure there's no bias, to make sure that their methods were set up correctly in a way that it's not going to affect the data in a negative way. So communicating results and repeating your work is very, very important. I hope this helps with you understanding the scientific method and the scientific process.